Welcome back to Aurora Tech Channel. Today, I will review the CR-10 SE. My first impression from the name CR-10 is something with a 300 by 300 by 400 print volume, but in contrast, the CR-10 SE is more like a high-specs Klipper version of the Ender-3 S1 Pro, from the size to the one-piece injection molded base and to the other parts. I remember when the Ender-3 S1 Pro first launched at the price of $499. After almost 2 years, it's still priced at around $373. The new CR-10 SE is $13 more and so far seems like a more appealing deal, but let's take a look at what we can get from it. The print volume is 220 by 220 by 265, which is 15mm more than the Ender-3 but 5mm less than the Ender-3 S1. The motion system uses a 12mm linear rail on the x-axis, a 24mm linear rail on the y-axis, and palm wheels on the z-axis. The y-axis also uses a NEMA 17 48mm high torque motor instead of the regular 34mm ones. The claimed top speed is 600 mm per second, and the maximum acceleration is 8,000 mm per second squared, which is pretty aggressive for a bed slinger. The extruder is a Sprite extruder with a K1 series hot end with a maximum flow rate of 32 mm3 per second, and it's equipped with a hardened steel nozzle that can reach up to 300 degrees Celsius. The part cooling fan is a 4020 12K RPM turbo blower, and it draws 7.2 watts, which is 3 times more than a regular 4020 blower. This machine doesn't come with any auxiliary fan. Inside the print head, there's another 32-bit chip, a strain gauge sensor for nozzle probing, a CR touch, and an accelerometer for input shaper calibration. As it comes with 2 sets of bed leveling sensors, it can use data from the CR touch and the nozzle strain gauge to automatically calculate the Z offset. The print bed can reach up to 110 degrees Celsius. There's insulated foam underneath and no manual leveling knobs, as the leveling relies solely on the CR touch bed leveling sensor. The Klipper OS runs on the screen, which actually works like a mini Sonic pad. With an Ingenic X2000 processor, the board comes with 8GB eMMC. The motherboard is a regular 32-bit board with TMC2209 silent stepper drivers. The touchscreen is 4.3 inches and runs the same screen UI as the K1 series, but a vertical version instead. It supports both cloud printing and local network printing with Wi-Fi. There are 2 USB ports on the side of the screen, which also allow you to print completely offline using a USB drive, and the other USB port is for an optional camera upgrade. For other features, it has a filament sensor, LED light, belt tensioners on both the X and Y axis, and a drawer like on the Ender-3 S1 Pro. The hardware of this bed slinger seems very strong. I would like to thank Creality for sending me this machine to review and for sponsoring today's video, and with that, let's get started. The box is pretty compact. It has a laser foam packaging similar to other Creality machines. Everything is well protected. We have the base, a 4.3-inch touchscreen, a dual spool filament holder, an LED light, a gantry with the print head, some tools, cables, and a user manual. Like all other bed slingers, we have to connect the gantry to the base and mount the screen at the right side of the machine. Mount the spool holder on top, and mount the LED frame at the top as well. Then, we will connect some cables, including the Z motors, filament sensor, and LED power. On the X-axis, there's just one stepper motor, and there's no limit switch as the machine uses sensorless homing. Connect the print head cable, which is a one-piece cable with an 8-pin connector. Finally, connect the filament sensor cable and the touchscreen cable. The power supply voltage switch is at the back of the machine. Make sure to flip it to the side that matches your local voltage. Once it is powered on, select your language, agree to whatever it says, select the SSID of your Wi-Fi network, and enter your password. If you see the SSID is checked and an IP address is showing, that means the connection is successful. Next, select your local time zone. In my case, I will select Pacific Standard Time. I won't connect this printer to the Creality cloud and just use it with my local Wi-Fi. Okay, it's going to run a self-test, starting with heating up the nozzle and the bed. Once it's done, it's going to set the Z offset automatically. The print head cover is too bulky, and I can't see what's going on here, so I will remove it and then continue. It probes the bed using the CR Touch first, and then probes it again using the nozzle. It's going to check a few different points on the bed and compare the data with the CR Touch and nozzle to find out the correct C offset. After it's done, it will perform a 49-point auto bed leveling. It seems the travel speed is quite fast, so let's see how much time is required to finish this 49-point bed leveling. It finishes the first row with 7 points in around 10 seconds, and for all 7 rows, it takes 1 minute and 10 seconds, which is really fast. After that, it will calibrate input shaping. The screen is showing a spinning cursor icon, and you can hear the print head vibrating, followed by the print bed. Okay, after about 6 to 7 minutes, it's done. The screen UI is similar to the K1 series, only vertical, but the menu structure and buttons are basically the same. We don't have anything on the onboard eMMC, so let's go to the settings and see if we already have the latest firmware. The machine already comes with the latest one, so we can just load some filament. Press the extrude button and the nozzle will heat up automatically. I will start with SUNLU Purple PLA. Okay, let's insert the USB drive and see if we have a sample fast Benchy to see what this machine is capable of doing. Let's try the 20-minute Benchy. For this fast Benchy G-code, the first layer is printed very aggressively. The print head is too bulky to block everything, but from the speed it moves, it should be close to 150 millimeters per second. Now the first layer is done, and the cooling fan is at full power. I will let it print another 2 layers and run at top speed, then check the sound level. I place the meter 6 inches away, and the sound level stays in the low 60s. The fan is actually louder than anything else, so even if the print head moves rapidly, it doesn't impact the sound level that much. The print finishes in a little less than 20 minutes. The print quality is decent. I can't see any cooling issues, and the surface quality also isn't bad. Let's compare it with the fastest printer I've tested so far, the Bamboo Lab X1 Carbon. The X1 Carbon completed the print a bit quicker in just 17 minutes. In terms of layer quality, the X1 Carbon is also better due to its Core XY kinematics, which might be challenging for a bed slinger to match. But surprisingly, the CR-10 SE outperformed the X1 Carbon in cooling, even without the auxiliary fan found on the X1 Carbon. It appears that an extremely powerful turbo blower, positioned at a close distance, still works really well for the CR-10 SE. Then, I will do a clearance test. I will use Creality Print to slice the number slider. The estimated print time is 3 hours and 4 minutes, so it seems the print profile is slightly slower than I expected. Normally, I would expect this model to be around 2 hours and 45 minutes. Let's take a look at the default profile. The infill and travel speed is set to 300 milliliters per second, the outer wall is 200, the top and bottom is 120, and the first layer is 50, which looks normal. For the acceleration, it is set to 5,000 milliliters per second squared for infill and travel, the walls are from 2K to 3K, and the first layer is 2K. The speed of this profile is slightly slower, but I will just leave it as I normally won't change any settings for test prints and just use the recommended settings and let the printer print right out of the box. So, I will just send it to the printer on my local network without using the cloud. On my screen, I can see the box is checked and showing a progress bar when uploading the file, but I'm not sure why the screen capture software didn't capture that. I tried to upload another file and record the screen using my phone, and it should look like this. The first layer looks good. It's a tiny bit lower than what I prefer. As for this number slider, I would rather have the Z offset be set a bit higher rather than lower, otherwise the first layer of the tiles may stick together. But I think it should be fine, as I can see a gap between them, so I will just let it finish as is and not try to manipulate anything. As this slider is just printing with the normal profile, it'll be slower than the 20-minute Benchy, but the sound level stays the same. I think the loudest sound is from the fan, so no matter if the motion system is moving faster or slower, it won't make a big difference, and the sound level still stays in the low 60s. The print finally finished in 3 hours and 21 minutes. The top of the print looks good, with almost no stringing, and the bottom has no issues, except I did have to separate one tile, as its first layer was sticking to the other tile. The clearance is also good, and the slider can move freely. Next, I will try a tough model my own honeycomb box design. It contains many tiny patterns, and it's a bit challenging for a lot of extruders to completely print the patterns. As you can see, the extruder just prints a drop of filament and needs to retract it immediately. The print finished in 2 hours and 52 minutes, and it printed successfully without broken patterns. There's a bit more stringing than ideal, so let's compare it to a few other machines that successfully or mostly successfully printed this model. This CR-10 SE is not the best or the worst, so it's pretty average. Then, I will do a decorative print, the Robo Alpaka from Prusa, to test the surface quality. The print finished in 5 hours and 45 minutes. The print quality looks alright. Let's take a look from all 4 different angles. The surface is mostly clean, with just a little ringing. Let's compare it to some new generation machines that used around the same time to finish this model. For the Ender-3 V3 SE, it took almost the same time, but the surface quality of the CR-10 SE is much better. When compared with the Encremic M5C, the surface of the CR-10 SE is slightly better, and the print speed is also faster. When compared with the Congro T500, which has a huge 500mm print volume, the print speed is almost the same, but the surface quality of the CR-10 SE is much better. Finally, when compared with the Prusa MK4, the MK4 has the best print quality, but also the slowest print speed. I will print another decorative model with some retraction, the Voronoi cat. The print finished in 6 hours and 5 minutes. The patterns are mostly clean, and the print quality is similar to the Bambu Lab P1P and Cheedy X Smart 3. However, the slicer profile didn't hide the Z-seam too well, and as you can see, they're everywhere. When I check the model in the slicer, the location of the Z-seam matches those on the model. When I check the model in the Prusa slicer, all the seams are hidden inside the pattern so you can't see them. As the cheaty slicer and bamboo slicer are based on the Prusa slicer, I created a profile in Prusa slicer that aligns with the speed and retraction settings of the extruder used in Creality print without any further adjustments. I resliced the model and printed it again on the CR-10 SE to see if I can get a better result. The result was not only significantly faster, taking around 4.5 hours instead of 6 hours, but also looks better on the print surface without the Z seam. Now, some viewers suggested that I should add an accuracy test, as sometimes we want to print a model that has to fit with another part. So, I created some simple geometry and tested with 0.1 all the way to 0.25 and tried to put the cylinder and square inside the other object. Let's see how well these parts can fit together. The cylinder is accurate, and the cube is also fairly accurate, but as these corners are overshot, like what you normally see on a calibration cube, it'll require some extra clearance. Let's start with the cube. 0.25 is clear, 0.225 is clear, 0.2 is clear, and 0.175 is also clear, but 0.15 may be too tight. If I forcibly push it in, I'm sure it'll get stuck in there. So for the cube, the clearance is up to 0.175. I think the cylinder can get a better result. It clears all the way from 0.25, 0.225, 0.2, 0.175, 0.15, 0.125, and 0.1. It seems when printing a cylinder without the overshot corner, the clearance can go as tight as 0.1 millimeters. Let's try some other materials. I will print an ABS crate. I will apply some glue on the bed to avoid warping. The bottom is printed nicely. There's zero stringing, and the patterns stick to the bed very well. As I've put a thermometer next to the print bed, the actual temperature of my garage is around 21 degrees Celsius. So, when the bed is heated up to 100 degrees Celsius, we can expect the ambient temperature to go about 6 degrees higher. Okay, the corners didn't warp, but as the ambient temperature is still pretty cool, you can see the ABS trying to warp, but the bottom still stuck well to the glue, so it caused the layer cracks here. After the print is finished, the temperature drops back to around 21 degrees Celsius. The corners stuck well, but it seems layer cracking is hard to avoid on an open frame printer. The pattern was still printed very well. Let's compare it to the one I printed last week on the fully enclosed Cheaty X-Mart 3. The layers didn't crack that much, just a tiny bit on the left, but the stringing is a bit more than the one printed by the CR-10 SE. Next, I will print a PETG pen holder. Since I just printed black ABS, I will purge more filament to clear out the black color. When compared to PLA, PETG sticks more to the nozzle. But overall this print is really nice, the surface quality is awesome, and I can't find any issues even when zooming in this close, so it's a really good print. Then, I will print a TPU wallet to observe the extrusion. Since this Eryone TPU is super easy to print, even a stock Bowden setup can handle it pretty well. I will speed up to 75 milliliters per second on this Sprite extruder. The extrusion is perfect, and even when printing TPU at a higher speed, there are no under-extrusion issues. Up next, I will print a set of nose pliers with nylon carbon fiber. As all my nylon filaments are stored inside the SUNLU dryer, which is a storage mode that will turn the heat on when the humidity is over 50%, the current humidity inside the box is 34%. I will just try to print it without any extra drying and see how it looks. I think the result still looks pretty good. The layers are clean, and I can't see any problems with the print. It's quite impressive to have to do nothing but just apply glue to print nylon carbon fiber on this machine. Finally, I will print a PLA sheet to test the auto Z offset and the auto bed leveling of this machine. The whole layer looks very good, and I can't see any imperfect spots. It can be peeled off without any line separation, so this is a perfect first layer. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The linear rail motion system works very well. The x-axis is a pretty standard 12mm rail, while the y-axis is a super thick 24mm rail that holds the bed without any wobbling. The y-axis also uses a NEMA 17 48mm high torque stepper motor to move the print bed rapidly without skipping steps. The z-axis uses palm wheels, but as it doesn't need rapid movement, the dual lead screws with dual Z-stepper motors and a timing belt should work well enough. 2. The Sprite extruder. When I previously tried upgrading an Ender-3 S1 Pro with Klipper firmware, this extruder actually worked well. The small heated block can't melt filament fast enough, even with the strong force of the extruder pushing out filament. The CR-10 SE is equipped with the Sprite extruder with a 60-watt ceramic heater, which has a much higher flow rate of 32 milliliters per second like the K1 series, so it works perfectly with the Sprite extruder. 3. The part cooling fan is a turbo blower. It's not only more powerful than regular 40-20 or 50-15 blowers, but it's even more powerful than the turbo blowers on other latest generation Klipper machines. It draws 7.2 watts, which is 2 to 3 times more powerful, and the cooling is as good as, or even better than a machine with an auxiliary fan. 4. The bed leveling is fast. It probes 49 points on the bed in just 1 minute and 10 seconds, which is even faster than other printers probing 16 points. The Auto Z offset uses the CR Touch as a probe to find the height of the bed. It then finds the height difference from the nozzle by using another strain gauge on the print head. This method makes a lot of sense, and the Auto Z offset value is very accurate. I could print a perfect first layer on the first try. 5. It comes with a bimetal copper shield hardened steel core nozzle like the K1 Max. This is better than regular hardened steel nozzles, as not only can it print high temperature abrasive filaments like nylon carbon fiber or polycarbonate, it can print low temperature filaments like PLA pretty well. I used the stock nozzle to complete all of my test prints, and all of them were printed decently. 6. The machine runs Klipper firmware, and the screen UI is similar to the K1 and K1 Max, but I found the firmware and screen UI on the CR-10 SE work slightly better than those on the K1 series. Without all those unnecessary AI features, there are fewer errors and false alarms. It doesn't need 5 to 7 minutes to calibrate before the print starts like the K1 or Bamboo Lab machines. So, it takes a more traditional approach, but still delivers similar print quality. 7. Creality Print is a fairly usable slicer. Its network feature is handy, especially for me, as I have a lot of Creality machines connected to my network. Some of them use the older Creality Wi-Fi box, some use the Sonic pad, and some new machines like the K1 series and the CR-10 SE are connected to the same network. You can just slice the model and select which printer you want to send the G-code file to, or directly start the print without touching Creality Cloud. The network feature is one of the best, even if the slicer isn't. Now for the cons. 1. Let's start with the slicer. When using the default profile, even with the same speed and acceleration, it always prints slower than the Prusa slicer. I think the main reason is it's using the Cura engine. But personally, I think the Prusa slicer is just better. One of the features I like most in the Prusa slicer is support painting, as you can add just enough support to make the model printable, but on Cura, Creality Print, or any other skin Cura slicer, you have to drag around a box, which gives you less control. 2. It doesn't provide root access. When I use SSH, I tried the root username and Creality_2023 as the password, which works on the rooted K1 series, but didn't work on the CR-10 SE. I checked with Creality, and they confirmed that root access is not available for now. 3. As the machine uses Klipper firmware, it should also leave the Moonraker API that lets you send prints over the network from almost any slicer. For now, if I want to use the Prusa slicer, I have to copy the file to the USB drive or upload the G-code using the web interface that looks like a simplified fluid, which is not too bad, but it would be much better to just send the job from the slicer. 4. The screen UI is pretty good overall, except that the print time is not shown when the print finishes. If I didn't film the entire thing, I wouldn't be able to know the exact time that each print took. For the web interface, the simplified fluid interface is the exact same as the K1 series, but Creality should get rid of the buttons that control the K1 fan and light, as they don't really apply to this machine, are all toggleable, but all do nothing on the CR-10 SE. 5. As for the hardware, I don't have complaints except that the LED light frame on top is quite fragile. Although it has a sticker warning against applying force, and I've instinctively tried to put my arm on it a couple times while standing next to it and watching it print. This light frame and sticker have been here since the Ender-3 S1 Pro, but I think there are probably better ways to install an LED strip on a 3D printer other than keeping the same design with the same reminder sticker. Next, when it comes to the PEI sheet, it would be better to use a double-sided one. One side could have the same textured PEI surface for printing PLA, PETG, and TPU, while the other side could feature a smooth surface similar to the K1 for filaments that require glue. In conclusion, this printer is essentially a fully upgraded Ender-3 S1 Pro, but it's selling at almost the same price. If you were to try adding all these features on your existing Ender-3 S1 Pro, it would probably cost you a few $100s and result in a Frankenstein-looking machine. For users used to the Ender-3 or Ender-3 S1 style machine, and like the workflow and easy repair and maintenance, getting the CR-10 SE lets you stay in your comfort zone while still enjoying the latest generation of Klipper firmware, enabling fast printing and convenient network features. This makes it an excellent choice for existing Creality users. The machine is also beginner-friendly. Overall, it's the full package, with solid hardware that lets you print a broad range of materials, with fairly good print quality and relatively fast print speed. So, this is a well-balanced machine with a reasonable price. On my 3D printer price tracker, if you're searching for a standard-sized printer with Klipper firmware, linear rails, and AutoZ offset, you may find that only the CR-10 SE and the Ender-3 V3KE meet all of these criteria. If you're interested in the CR-10 SE, I included the link to it as well as to my 3D printer price tracker in the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.